to do the startup testing. Major decision, major decision. Don't have the construction contractor do the startup testing. Have your own engineers in charge of that on a new plan. That's all I have to say on this subject.
I might just add, it certainly was refreshing to have authority at the local level. Washington, D.C. is a long way away from Hanford, and it's just, there's wear and tear involved in that sort of thing. This is before we could have video conferences and so forth. And so having local authority to direct things really did streamline things. And as Bruce pointed out, they weren't just administrators, they were technical people who wanted to get the job done. I might just make one other comment regarding this general organization. I think if we kind of take the clock back a ways, there was apprehension early on that maybe faster reactors wouldn't be as safe as thermal reactors. I mean, after all, they've got sodium in there, and sodium can react with air and water. The delayed neutron fraction is less with the plutonium in the reactor, and we know that these are controlled by delayed neutrons. Lifetime is shorter, they're fast neutrons and so forth. And there was a general feeling, I think, that, golly, we've got to be very careful. Well, we do. Safety, of course, is very, very important with any nuclear reactor system. In fact, it's so important that, as we all know, the Atomic Energy Commission itself was divided to DOE, ERDA originally, and the NRC to make sure that safety was in a separate organization. This has been a paramount feature. And so the decision was made early on in the case of FFTF to have the safety organization separate from the construction organization, so that in fact, because these were the people that had to sell this thing, if you will, to the Nuclear Regulatory Commission and whatnot. It was a very amicable kind of thing. I don't want to say there was any animosity, but the fact is it had separate authority, and this was important, even in the design. Safety is not something you tack on; it's built into the design. The control rods, for instance, you want to have a lot of reactivity so you can shut the thing down, but you don't want to have too much reactivity, any one control rod, because you have to worry about, well, what happened if somehow inadvertently one control rod was pulled out when you didn't want to have it, and that would have safety implications. So that kind of a balance was very, very important. And having that separate safety organization under Dan Simpson, I think, really did, in fact, streamline the project. It still took 2.5 years to get the preliminary safety analysis report approved, another 2.5 years for the final safety analysis report, but it was all done with integrity and credibility, and I think that this really served the plant very well.
Well, coming in on the ground level, I didn't see intimate details of the project and management, but I did get drug in to ensure the project management folks that the acceptance test program was actually complete. So I was involved in many meetings of those kinds of nature that as we approached the initial startup of the first operating cycle for the reactor, we were trying to ensure that all the testing had been done, that all the installations were complete, and that everything was going to operate correctly. So I think the impressions I got, being on the ground floor, I guess my opinions were that there was not an adversarial type of relationship. It was a community kind of thing. The decisions were done in that kind of mode. They were done together. A lot of the things, it wasn't the kind of thing where Westinghouse had to bend over backward to try to prove to DOE that something was correct. There was more of a joint progression toward that decision, and when it came time to make the decision, everybody was pretty much on board. There was no salesmanship involved. Everybody had been through all the details on the decision. So I think that in itself was a unique project organization where the customer and the client met and dealt directly with the contractor and worked together to get decisions made and to get the right decisions made.
I think before we move on to the next topic, I'll just make one summary note. We have alluded to major decisions that were made along the way, and at least 3 of them, okay? Bruce Nordhoff alluded to one, and that was the decision to do the turnover of the reactor system by system such that the engineering and operating organizations would know the reactor, and the architect, engineer, construction manager was responsible only for co-testing. Thereafter, the reactor plant and the testing belonged to Westinghouse, Hanford, or Heddle. It's a major decision. Bruce referred to that. Alan referred to another major decision, and that was that the manager of nuclear safety or reactor safety at the time reported to the president of Westinghouse, Hanford, or Heddle. Therefore, the president of the performing organization here, Westinghouse, Hanford, or Heddle, was not only responsible for the design and the construction reactor, but also for the safety of it too. And in the staff meeting sent the director of nuclear safety. And I think the third major decision that we referred to was to locate the project office, not Bruce's, Chuck's 60 people here on the site. That prevented positions being developed over time because organizations were distance away and the positions hardening, and then you have to either capitulate or negotiate. I mean, they were just right down the road. They had as much information as Westinghouse did. You could sit down in a meeting and exchange information and share information and arrive at a decision because they were on the site too. So those are key major decisions, at least we discussed so far on this project.
The word team comes to mind. It was a very, very harmonious team. Safety was invited in, not stiff-armed out. And they did a heck of a job, and we had no fatalities during the construction. We had one serious injury when a man fell outside the plant and injured himself. That was the only serious one. But it was a very harmonious project.
Our next topic we'd like to discuss is project control, which was a rigorous discipline method on FFTF. And again, we'll start with the client's perspective on project control.
Well, engineering, schedule, and cost control by means of work packages during completion of construction and turnover was a key part of the project. Total construction budget authorization rather than authorization on a year-to-year basis was a key part of this whole project. The capital, once the cost and schedule had been firmed up, the capital cost of the project was authorized on a no-year basis. This allowed the government project office to have full control of the total resources for the project, and meant that they could firm out the total schedule for this project, firm out the work packages, budget those, establish a contingency fund, and control to that system for the total life of the project. The construction project manager under Heddle managed these project packages with approval control by the FFTF project office. That was a means of controlling to the cost and schedule, and it allowed us to complete on schedule and on time for the project.
And now we'll hear from the Westinghouse manager, who was the implementer or performing organization here in this project control system.
Well, I have some difficulty in talking to this area of finance because the field work was funded based on milestones and pressure and what have you. I didn't get much into the financial world as we were doing the various field jobs. I do have one thing to say. The costs were determined strongly by having the field staff be adequate. The project benefited enormously by having field engineers in sufficient quantity for each of the systems to get the job done. If we had been less fortunate in having key people transfer from Battelle to Westinghouse. Westinghouse Pittsburgh, the Advanced Reactors Division, designed FFTF with Battelle. Transferred out here. We had people from Aerojet in California, people from Atomics International. When their work in California diminished, we recruited them and hired them. We built up a staff of test engineers to augment the design engineers that was field able, skilled, and it allowed the program milestones to be met, and we were able to get coverage on back shifts and weekends and you name it, because we had the staff of engineers. Lastly, a project decision was made very early that decided that test engineers would conduct startup testing and not operations or construction. That was a key decision in the project. Make the early decision as to who's going to do the startup testing program. We made that decision very early and elected to go with a test engineering group, and we had powerful teams built as a result of that decision. Operations was responsible for the plant condition, operating the plant in support of all the testing. So they got to know the plant, and the engineers got to use their knowledge of the system to help operations. It turned out to be a wonderful decision, but it was a key decision very early, which allowed us to organize with this recruitment and get strength. And that would be my remark. Those are my remarks on this topic.
Thank you, Bruce. And Alan?
Well, again, in the as Chuck pointed out, having a budget that didn't depend on year-to-year fluctuations by some congressman someplace had an enormous difference. We're making this tape in 2010, if you will, and you know, this is wind the clock back a ways, but Congress has always been somewhat flaky, and you just can't run programs like this with ups and downs. I just returned from a conference, an IAE conference in Abu Dhabi, and one of the clear examples of a country that has gone essentially from nothing to a world-class power in nuclear power is Korea. And it's because they've had constant governmental support. They started in the 50s with nothing. They were flat on their back, decimated to the war. But because they've had constant support and budgets haven't been a concern for these kinds of projects, they are now becoming world-class. They've sold 4 reactors to the UAE, which is probably the first new entrant country. And I think that kind of situation existed during this time frame. For instance, in the safety world, we were having experiments run in many, many places in the country, both in physics, safety, materials interactions, because we were dealing with the regulatory process. You can't stop an experiment in midstream someplace. You have to be able to carry the thing through and get the results. We had a very transparent relationship with the NRC. But nevertheless, we had about 24 separate meetings, official meetings, in concluding in getting resolution on the preliminary safety analysis report, another 24 to get the final safety analysis report done. These were all, of course, very carefully documented because it is a regimented process. So there's very, very careful project control. So we knew each side knew exactly where we were. But the point is we could move ahead like a D8 caterpillar instead of whipping around like a grasshopper because we weren't subject to fluctuations in budgets when we needed the budget to continue the process. So that kind of continuity and support, I think, was absolutely crucial in completing the safety reviews in parallel with the construction process, so that when we got to the point where we were ready to do startup testing and actually bring the reactor up, that we had complete concurrence. That was very, very important.
To expound a little bit on what Bruce was saying about design engineers and test engineers and that type of thing, I remember, coming in as a test engineer, going out in the field and actually running tests and doing those kinds of things. The systems or the components that were under test were isolated from the rest of the plant, so that you couldn't affect what was actually up and running and working right. You isolated that system so that the system didn't really affect anything else. And then as a test engineer, we actually went out and ran that system, like Bruce was saying, sometimes with the help of operations if we needed them to supply us power or something of that nature. And brought in craft to do some things too. The design engineering groups then relied very heavily on recruitment from, in a lot of cases, you could see continuity from a design aspect being done at a supplier to that equipment being built and then provided to FFTF, and the design engineer actually coming then to FFTF and becoming the design engineer, the COG engineer for that equipment. So a lot of continuity that happened in that regard, and that was very helpful. Test engineering, and we as test engineers were somewhat isolated, somewhat independent of the design function. We would actually go out and probably in some cases made the design engineers somewhat queasy, because we would actually take their equipment and their designs up to the design requirements. We wouldn't exceed those design requirements, but we would try to get them to the design requirements, which were in most cases quite a bit higher than the actual operating conditions. And so we were trying to prove that the design actually was sufficient to meet and operate at design requirements if need be. So that was, in being a test engineer out in the field, that was an interesting aspect of that whole thing. We did enjoy doing that kind of thing. And then if we found something, we would work then with the design engineer to try to make a change and get things corrected so that things would work better. So having the funding, and that was brought out too, having the funding available to get enough people out there doing that and not having to worry about, are you going to have your staff next week or next month or next year? We were able to plan through that whole thing and make sure our staffing levels remained constant, and the people didn't leave and then have to come back or go somewhere else and have to come back, that kind of thing. So that was, I think, key.